everybody. Today we proceed to counting rules, which is at the end of this session. You will be able to know what is MN rule, what is permutation, and what is the formula for combination rule. First, look at MN rule, which is multiplication rule. What is the rule? The rule is a formula for counting the number of possible outcomes of a single experiment when sampling with or without replacement has been used. This rule is used to fill k different slots. What is the k? K stands for what? K, we'll discuss the function of k later based on the example. Next, let's say we have two events, which is event A can happen in M ways and event B can happen in N ways. Then both events can happen in M times N ways, which is we use MN rule. But this rule can be extended for more than two events, not limited to just event A and B only. Look at first example. Zafran wants to buy a new car. There are 8 choices of interior colors, 10 exterior colors, and 4 roof colors. How many possible color schemes are there? So you have 3 different slots. What is the slot? This is the first slot, second slot, and then third slot. So this slot refers to k different slot. Look at the solution based on 3 different slots. 8 times 10 times 4. So you got 320 different color schemes. Second is permutation. So permutation is used to arrange the elements or objects of a set into a sequence or order. So the keyword here is the word arrange. There are basically 2 types of permutation. First one is the number of permutation or arrangements when order is important. Order is important on n different objects. Second keyword, taken are at a time without repetition. Third keyword is given by this formula NPR. You may look at your calculator and you can find this formula NPR. So look at example 2. In how many ways can 10 people be seated on a bench if only 4 seats are available? So, what is the first keyword? Order is important. So this one, 4 seats are available. Second keyword is different object. So different object refer to 10 people. So this one is second hint or keyword. Third is without repetition. Means only 1 people be seated for 1 seat. Therefore, 10p4. The answer is 5040 ways. Okay guys, we proceed to second type of permutation, which is the number of permutation or arrangements when order is important of an object with some objects are the same selected without repetition is given by this formula. For example, let's say the word Aiman. So Aiman, A, repeat twice. So for this word, we may use second type of permutation. Look at third example. In how many ways can the alphabets in the word statistics be arranged? Okay, so first, why we say it permutation? The keyword here is arrange. Okay, so how to solve this example? First step, list down all the letters in the word statistics and the frequency of each letter. Okay, so look at this list. You have S, 3S, 3 T's, 2 I's. Therefore, we must use second type of permutation, which is by using this formula. So, substitute all the value of each n into the formula. At the end, you will get 50400 ways can the alphabets in the word statistics be arranged. Okay guys, so this one is combination. So this rule is a formula for counting the number of possible outcomes of a single experiment in which sampling is done without replacement. So the difference between combination and permutation still single experiment, but the experiment can be conducted either sampling is done without replacement or with replacement. So now we focus on combination, which is sampling is done without replacement here. And the order in which the outcomes occur is not important. The order, okay, is not important. So this rule, we may use this formula NCR. You may look at your calculator and you will find this symbol. So look at example 4. Find the number of committees of 8 persons to be formed from 15 persons if there are no restriction. No restriction means no condition. Okay, so based on this example, why we must use combination? So look at the keyword here. 8 person. So person means you conduct the experiment without replacement. Next keyword here is the order of the outcome occur is not important, which means that how you want to get 8% from 15, up to you. There is no order, there is no arrangement, just select 8 out of 15. So solution here is 15C8. So you got 6,435 ways. Proceed to example 5. Find the number of committees of 8 persons to be formed from 12 men and 8 ladies if there are 5 men and 3 ladies in the committee. So how many men? 12 men. But you just choose only 5. Next, how many ladies? 8 ladies. But you just choose only 3 ladies. So, based on this information, you may use combination to solve this example. Look at the solution. 12C5 means 12 men. Select 5 and combine. Ladies 8. Choose 3. So the answer is 44,352 ways. We proceed to example 6. There are 8 finalists in a drawing competition and 4 prizes are awarded. In how many ways can the finalists win the prize if there are first prize, second prize, third, and fourth prize? So, how to solve this example? Permutation or combination or maybe MN rule. Which one? Recall back. Based on information, you may use permutation. But which type? First or second type? Look at the information. 8 finalists. So this one is you conduct the experiment without replacement. Means one finalist may won only one prize. Then the order is important. First prize, second prize, third prize, and fourth prize. So you may use permutation 8p4. So the answer is 1680 ways. Then, you also can solve this example using MN rule. Why? Recall back. Basic concept of MN rule. You must have k different slots. So based on the example, how many slots? 4 slots. So, how many finalists? 8 finalists. Reduce 1. Reduce 1. And last one is 5 finalists. Next, 8 times 7 times 6 and times 5. So you got same answer as permutation method. 1680 ways. Proceed to example 7. How many different permutations can be formed from the word coronavirus if the last letter must be O? So this one direct question. Why I said it direct question? Look at this word permutation. So direct. You may use permutation to solve this example. Then if you use permutation, what is the first step? If you are given a word, list down the letter and the frequency for each letter. So based on this list, you can see that you have 2 O, 2 R. Means that you can use second type of permutation to solve this question. But extra condition here, the last letter must be O. So you have 2O, but the condition last letter must be O, so reduce by 1. So right now you have only 1 O. Therefore, total number of letters also reduced by 1, which is 10. Solve the question. Second type of permutation. Therefore, 10 factorial divided by 2 factorial. So 2 factorial based on letter R. So the answer is 814400 ways. Next, example 8. Given the digits 1, 2, 3, 4, 5, 6, and 7, how many 3-digit number can be formed if repetition is not allowed? Means that this experiment conducted using sampling without replacement. Based on this statement, repetition is not allowed. So, you must use permutation. permutation. How many digits? 7 digits, but you just use 3-digit number. Therefore, the solution is 7p3. The final answer is 210 ways. But for this example 8, you can also use MN rule. Recall back MN rule. How many K different slots from this example? 3 slots based on this question. 3-digit number, so 3 different slots. Okay, how many digits? 7 digits given. So 7 and then reduce 1, reduce another 1. Therefore, the answer is same as using permutation. 210 ways. Okay, now we proceed to example 9. How many different arrangements can be formed from the word suka, suki? If letter U must be together. So, based on this example, what is the direct information given? The word arrangement. So, you must use permutation. Based on word suka, suki. List down all the letters and the frequency for each letter. Okay, next step. What should you do? Look at the condition. The condition here is letter U must be together. How many U? 2. So, if letter U must be together, make it as one group. Therefore, total number of letters equal to 7. The solution is 7 factorial divided by 2 factorial times 2 factorial, which is equal to 1260 ways. Okay, next. What happens if you have the word suka, suki, you? So, from this letter, you have 3 U. Let's say the condition is same. The letter U must be together. So, what should you do? Same concept. Make it 1. Therefore, total number of letter from the word become 7. So, what is the solution from the word suka, suki, you? If letter U must be together, same solution, which is 7 factorial divided by 2 factorial times 2 factorial. Final answer is 1260 ways. Okay, proceed to example 10. A trainer must choose 5 trainees from a group of 10 trainees. How many different ways can the trainer choose the trainees? So this one, sampling without replacement. How many trainees? 10 trainees. But you must choose only 5. The word choose means you must use combination. Therefore, 10C5, which is equal to 252 ways. Okay, we proceed to example 11. A bowling team consists of 4 people is to be formed from 10 students and 8 lecturers. Find the probability to select the team if it consists 2 students and 2 lecturers. Second question, at least 2 students. Okay, this example is different from previous examples. Why I said like that? Look at the question. Find the probability. So, based on the question, you must use probability concept to find the final answer of the question. First, identify. You must use permutation or combination. Recall back. Concept of permutation, concept of combination. So which one you want to use? The answer is combination. Why? Why you can use combination, not permutation to solve this example? Look at the example. What is the question? To select the team. So you conduct this experiment using sampling without replacement, and the order is not important. Select 4 out of 10 students and 8 lecturers. So back to question, you need to find the probability. So you must use this probability concept. PA equal to NA over NS. A is the event. So what is the event? To select the team if it consists 2 students and 2 lecturers. What is the NS? So S represents sample space, means no condition, no restriction of the selection the team. Okay, so this one is solution for first question. Probability to select 2 students and 2 lecturers. How many students? 10. 10 you choose 2. Combine with how many lecturers? 8. But you choose only 2. So 10C2 times 8C2 divide by sample space means no condition. 18C4. So final answer is 7 over 17. Okay, proceed to second question. At least 2 students. At least means minimum is 2 students. Maybe 2 or maybe 3 or maybe 4 students will be selected. Okay, so this one is solution. Or means you need to plus and you combine. So the operation is times. So this one is solution. 10C2 times 8C2 plus 10C3 times 8C1 plus 10C4 times 8C0 divide by sample space 18C4. 4, 2 plus 2 equal to 4. 3 plus 1, 4. 4, 0, 4. So, final answer equal to 27 over 34. So, this one is example to solve the question if you need to give in probability form. So, guys, you may try this quick check and check the answer. Okay, that's all for this session. Thank you for your meaningful time to watch and learn via GH Sunshine. Assalamualaikum and dah.